Okay, so we fixed the error. We drew the subdivision boundary. We checked the error of less than 0.03, so we're good. So the next thing we're going to do is to start drawing in the center lines. That's pretty much what I've explained already. That the next thing to draw to recreate a full plat would be to draw the center lines. Okay, so as far as the center lines, these here and these here, what I draw next, you would essentially have to do some adding if you wanted to. That's one way, just to show you how that would work, would be to add some information. For example, if I wanted to draw this center line, where do I start it from? You have to add 8484, which is the distance along the boundary from here to this point. And then 5116 is from this point to this point. I can do that. I can do that. And if I wanted to, I can do that and draw that center line. Okay. But and then to find that point, the way I would do that is add the two, and then like I said, you would start from this corner over here, and then you can draw yourself a circle. As a matter of fact, I'm going to draw two circles. One circle from this corner here of the 8464, and I just like circles. They work really well. They work really. I'm sorry, 8484. They work really well because I'm able to use the circles, and then I can draw myself another circle, and these are just temporary circles. 5116 would be the two circle radiuses. That way, I have a point that I can use, so I can start creating my line by bearing from this intersection. What is my bearing? You'd have to look at the bearing and distance of the center lines, and there it is. So you have the this one right in here, Southwest 50, 89, 58, 40, 150. Okay, that is one way, and I can just continue drawing the center lines and just continue drawing all these other ones, and then draw the right of ways, which would be obviously once we have the center line drawn, then we can offset 26 feet and establish our right-of-way lines. Okay, so we can do that. We can do that. Now, in this one plat in particular, I'm going to kind of study a little bit and notice that the boundary, which is why the boundary is so important, because look at the boundary bearing of 89, 58, 40. Look at the center line bearing, southwest 89, 58, 40. Okay. These two lines are parallel, and not always the case. Not always the case. So if it's not, you'll have to do this whole technique and draw that center line if they are not parallel. These are. So then another thing I'm looking at is I'm looking at the distances of the lots. These are all 110s. All of them are all 110s. So then what could I do in an AutoCAD basis to establish and draw most of this right away? I can offset. How much? 110 feet. So in this case, I can do that. Not always. You just need to study your plat a little bit and see if you can do that. So here, instead of doing this whole exercise, what I can do is I can just simply offset 110 from here to the right-of-way line. And you got to pay attention to what you're drawing. So I'm going from here to the right-of-way line. I mentioned center lines, but I can just go 110 and then 26 and 26 to then establish the entire right-of-way, including the center line. So I'm going to offset 110. We'll then offset 26 feet and then 26 feet. Okay. Before we get too far, let's start putting things on layer because it's going to start getting real complicated. Which layers do I want to use? The boundary, as far as the layers that I want to use for the boundary, I want to use a layer called C prop boundary. C prop boundary is going to be the layer specifically for the boundary of the subdivision. C prop boundary. Okay. For the center line of the road, that's why I'm doing this now, I don't get all confused, because you can pick the wrong one and it'll just get messy. So I just want to make sure you're realizing what you're drawing. For the road center line, there's going to be a C road center layer. And these are layers that are created already on Civil 3D, C road center. Okay. There is no right-of-way layer. So the one that we've kind of adapted to use for this, we're going to go ahead and use C road core, because the right of way we're going to draw in 3D a little later in the semester, and it's going to be considered a corridor. So we'll just go ahead and use the right of way lines and put them under the C road core layer. for the right-of-ways. Okay. Now, as far as this side, could I do the same thing on that side on the plats? Let me go look. I have a bearing southeast 02440. I have another bearing southeast 02440. Excellent. 105, 105, 105. So that's not 110, it's different. But are the lines parallel from the boundary? They sure are. So once again, I can offset 105, 26, 26. I know that because it says that on the plat. And I'll have most of this right-of-way drawn already. Okay, I'll have most of that right-of-way drawn already. So 105. I'm going to go back over here. Offset 105. Here this way, 105. And then 26 feet. 26 feet. So I don't lose track of where I'm at. I'm going to go ahead and match properties, MA, and match this one with this one. And this one, that's my right-of-way lines. And then match properties of the center to the center. Just by doing that, obviously we still have way more work to do and extending and all that, but at least I have most of it done. Quite a bit of it done, actually. Most of this all right in here, okay? So there's still some more geometry we need to work with, but let me just kind of continue. So for now, what I'm going to do, I guess what I'll do, let me think about this. I think what I'll do is I'll go ahead and round this part out, which is this round part in here, C32. So I can actually use my AutoCAD fillet command with a radius of the C32, 30. So that's the radius. If you look at the curve table over here, C1 or C32, and then the first column is the radius. So the C32 radius is 30 feet. So just using my AutoCAD command of fillet, F for fillet, R for radius, I'm going to change that to 30. I'm going to fillet between this line and this line to fillet that one at 30. Okay. Before I get to the cul-de-sacs, let me show you how I'm going to draw this turning heel. The turning heel. That's what this technical term is over here for this guy. Okay. Usually, I would say about 80% of the time, this turning heel has a radius of 70. The center of the turning heel usually is the midpoint right in here of this arc, usually, okay? Not always the case, but let's find out if that's the case here. So if I draw myself a circle from here with a radius of 70 feet, I should get this turning heel. That's usually the way it works, which is why I need to draw this one in first. So I'm going to try that. Draw myself a circle from the midpoint, MID, from here of 70 feet. So it looks pretty okay. I just don't know if it's in the correct place yet. So for now, I'm going to trim just to get most of this turning heel in what looks like it's in the right place. The center line is pretty much squared off. So I'm just going to leave that intersection. So I'm just going to go ahead and trim and erase these. Okay. Before I finalize this thing, let me make sure it's in the right place. How do I know it's in the right place? Well, there's a lot of different ways. The lot lines is actually the last thing we draw, but I will tell you here, I'm going to use the lot lines. I'm going to use them and draw them to tell me. I'm going to draw probably that one. I'll start with that one. Once I draw one, I'll find out right away if this is in the right place. The lot lines are the things that we draw last. In this case, I'm going to use one lot line to tell me, is this turning heel in the right place? I'm going to come from the corner 51 feet. At that point, I will draw a line southeast 1635, a distance of 138.18, to see if this turning heel is in the right place. So I'm going to use a lot line to help me determine that. So I'm going to come over 51 feet. I like to use circles. I'm going to draw myself a circle from this endpoint, a radius of 51. And then I'm going to create a a line by bearing into it says southeast. I'm going to go opposite of southeast, which is northwest, 35, 16, 35. 35, 16, 35, a distance of 138, 18. Just by me drawing this line, I can tell right away it's not in the right place. If you're following along with me, let's check to see how much the error is. Remember, as long as it's not more than 0.03, the error here from this endpoint to this intersection, it's 1.5806, way over 0.03. Okay, that's already telling me right away this turning heel is not in the right place. We're not too far off. It's only a foot and a half, but still, we need to find that out. Okay. All right. So when you're drawing a plat, if you don't know these techniques I'm about to share you, how would you draw it? You would actually have to draw a little arc, another little arc, another little arc, another arc, another arc. But that's not good. That's actually adding error to it, too much error. So then the magic to this is to try to find that center point. We already know it's not here. So where is it? Where is it? Okay. So let me show you this technique. It's not the only one. There's tons of different techniques. It just happens to work for this one. It's, if I select this thing, I can tell you this is where the center point is at. So I'm just gonna investigate it and try to see. I'm gonna take a distance from the center of the turning heel. It's gonna go perpendicular to the boundary. That distance is 165.85. Okay, well, that doesn't make a whole lot of sense. Distance from the center of the turning heel perpendicular to this boundary. 170.85. One was 165.85, 170. I will tell you right now, engineers love round numbers. There's no reason to work with 0.85 or nothing. So I suspect this engineer, which happens to be Conde Engineering, it's a public plat, there's nothing secret about it. I didn't steal it from them. I think Conde Engineering actually did an offset at 170. I can almost guarantee. I don't know why. It just looks like it's headed towards a 170. This is pretty close to. Yeah, it's going to be 170. Let's see if that's the case or not. So we already know this is in the wrong place. I'm going to delete this guy. I'm going to offset this boundary 170. It doesn't have to be that way. It just, again, this is this one scenario. Notice this really has nothing to do with it. It's just kind of it's not anywhere close, but I think it's going to be that intersection. I can almost guarantee it's going to be that intersection. I'm going to draw myself a circle from that 170-foot intersection right here with a radius of 70. If I look at my lot line, look at that. Zoom in there, and sure enough. How much error are we talking about? 0.0024. Excellent. That's the location of it, okay? And we further prove it. We probably should. Why don't I draw myself another lot line, this one right in here? Let me draw myself another lot line, a distance of 102.10 from this point. Bearing and distance of southeast 659. So let me see if that's really going to be the case. So I'm going to leave this one. It looks pretty good so far. 102.10 is my radius. Create line by bearing. From this intersection, it looks like it's southeast. So I'm going to go the opposite of southeast, northwest. 6.0509. Distance of 100.96. I drew that in incorrectly. 60509. 60509. Let me try it again. Create line by bearing. 60509. Yeah, I think I typed it in incorrectly. 100.96. Looks very good. We're always going to have those little errors. Double check to make sure it's less than 0.03. And it sure is. It's 0.0036. Excellent. I found the center point of the turning heel. You don't have to find the center point of the turning heel. I'm going to go ahead and trim. You never want to trim. You never want to leave little gaps or intersections. I had checked this one before, so I'm going to trim that one. You try to. You don't have to, but you try to find those center points. It just minimizes the error. And now that we found the actual center point of that turning heel, that's will make laying out these plats a little bit easier. So I'm going to match properties here. I can do a fillet in here, and continue with the rest of our center lines. I'm going to go ahead and continue with the next video to show you how to draw some of these cul-de-sacs, the reverse curves. We do need to draw in some reverse curves up in here for these right in here, but I'm going to go ahead and draw that one and show you how to do that on the next video.